Next topic, recursive functions. Some of you might be looking at this and going, oh, that looks a little bit like a piecewise function, and you would be absolutely right. It does look like a piecewise function. So throughout the 4 courses you take in computer science, mainly with me, the 4 courses, you get a little recursion here, a little recursion there, and a little now. And it's different pieces to put the whole thing together. Like those of you that are in 162, I think there's only 1 or 2 of you that are in 162. You're doing stuff right now with recursion, and you've got it a little bit, but if you had to write it, it would be really difficult. So we're going to take a look at how I would solve a recursive function. Now I'm going to take a look at number 2 to start, and I have a call for function f1, 3. So these are like my arguments, okay? I'm passing 1 and 3 over to my parameter list, and it's going to land here. And I have 3 choices. So when I see choices, I know if I had to write this as a program, I would be doing an if based on what my values are for x. So right now, x is greater than 0. So f1, 3 is going to go to this first line, and it's going to say it becomes 1 plus f of x minus 1, which is now 0, comma, the y value is 3. So that means I'm going to have 1 plus, and now this is where that recursion starts to go deeper, goes down and down and down. In order to solve this, I now need to find out what is f of 0, 3. Because once I find this, I'm going to spiral back out of the rabbit hole and be able to find out what my final answer is that I want up here. So now f of 0, 3. I come in, my x value is 0. It says, okay, this time I want it to be y, which is 3, plus f of y minus 2. 3 minus 2 is 1, comma, x, which is 0. So that's going to become 3 plus, now I need to go find f of 1, 0. Now, these first 2, some of you may know, these are called the recursive cases, where it's calling the function again, or the method, whatever you want to use for terminology. It's calling it again. This guy down here would actually be called a base case, because it ends, it doesn't recurse again, and it would go back up. There would be no recursion. F of 1, 0. Let's see, my x is greater than 0. That's going to be 1 plus f of 1 minus 1, which is 0, comma, y, which is 0. Now I need to find f of 0. Okay, f of 0, 0 hits this middle row. It becomes 0 plus f of negative 2, comma, 0. 0 plus. Now I have to find f of negative 2, comma, 0. Finally, I'm going to hit that base case. What is f of negative 2, 0? 0 minus negative 2 is a positive 2. I can plug that back in up here. That gives me a 2. I can now plug that in for f of 0, 0. That gives me a 3. I can plug that back in for f of 1, 0. That's a 3. I now know what f of 0, 3 is. It's 6. Final answer is 7. If I had to write this as a method.
I have a question.
Yeah, go ahead.
Isn't f of negative 2, 0? Wouldn't that be negative 2? Because it's x minus y?
Oh, yeah. Oh, crap. That's -2, that's -2, that's -2, that's -2. That's -1. Glad I'm not recording this. Oh, wait, I am. That's -1. That's a 2. That's a 2. Final answer is 3. Is that better? I do make mistakes sometimes on purpose to see if anybody's paying attention. You're buying that, right, Travis? Travis, yep. You can just nod. Yep. Thank you. If I ask you to write this as a function, public, static, I think I'm working with inch, right? My function name is f, int. I'm just going to use n. If x is less than 0, else if x equals 0, equals, else, I need int n1 and int n2, don't I? Sorry about that. So I don't need x, do I? What do I need here? I'm calling this first parameter n. So my apologies again. We are sloppy I am sloppy all over the place. If n1 is less than 0, why didn't somebody tell me to call these x and y? Let's write it again. Thank you. Public, static, int, f of int x, int y. Jeez. Parentheses, if x is greater than 0, else if x equal 0, else. The else is easy, right? What am I doing?
Return x minus y.
Good. Return x minus y. If it's greater than, what do I do?
Return x plus f of x minus 1 comma y.
Yeah, good. And return, I don't know why I put an equals there. Y plus f of y minus 2 comma x. Okay. Cool. Yay, let's do another one. All right, all right. I know you're excited. Do a little nicer than the last time. Pick a number, any number. What number do you want to do? 4. Anybody?
1.
Good, let's do number 4. 1. Let's do number 4. F of 5. F of 5.
That'd be the third case.
Yep. That's going to equal f of 3 times f of 4. How's that? Now it's straight. All right, so now I need f of 4. And I'm also going to need f of 3. Hopefully I didn't screw that one up. Julie, did you get negative 144?
Sure, after I copied what you did.
You trusted me. After the way I screwed up so far, you trusted me. Oh, man. Did anybody get negative 144? What the heck's the answer key say? The answer key says negative 144. I got it right. I got it right. All right, number one, see what you can get. Number one,
What's that say? F of 100?
yes. Hmm, 99 over 100 times 98. How's about that? I got 1 over 100. Anybody else? Yeah. Cool. Let's do one more. I'll even do the number you pick. Couple pages to choose from. Anybody? Everybody. Nobody has a question to pick? We think we got it? This will be an easy one on the selected topics quiz. There we go. Number 6. Number 6. I have f of 5. F of 5 is going to fall into that first category. It's going to become f of 3 minus 3. F of something minus 3. Now we're crooked again. All right, so now I need f of 3. F of 3 is going to still fall in that first category, is going to be f of 1 minus 3, which is going to be f of something minus 3, which is f of something. Looks like I now need f of 1. F of 1 falls into still the greater than category. Huh. F of negative 1 minus 3. F of something minus 3. F of something. F of negative 1. What is f of negative 1? I got a 1. Put that in. This now becomes f of negative 2. What is f of negative 2?
2.
2. So now I end up with a 2 here. So f of 1 equals 2. I can put it back up here. And now I have f of 2 minus 3, which is f of negative 1, which I already know is 1. So f of 3 is the same as 1. I put that in and I get f of negative 2. Final answer, 2. I needed f of 3. In order to get f of 3, I needed f of 1. In order to get f of 1, I needed f of negative 1, which was 1. So I put the 1 in, subtract the 3, f of negative 2, which I know is 2. Now that I know what f of 1 is, I can replace it up here. 2 minus 3 is negative 1. F of negative 1 is 1. Now that I know what f of 3 is, I can replace it up here. 1 minus 3 is negative 2. I already know what f of negative 2 is. It is positive 2. What would f of 7 have been? Any guesses? Here's f of 1, f of 3, f of 5, f of 7. I'm guessing it's probably going to be a 1. Looks like there might be a pattern going. Okay, any questions?